Good day again. Welcome to Module 12. Alright, so we're looking at the application layer services. So look at the network application service, the domain name system, the web client and servers, FTP client and servers, virtual terminals, email, and messaging. Alright, so let's look at the network application service. So what are the most common internet services that you use on a regular basis? Alright, most times you use the file service, web service, and most likely email service. So for most people, the list includes services such as internet searches, right, social media sites, video and audio streaming, online shopping sites, email and messaging. So each of these services relies on protocols from the TCP/IP protocol suite to reliably communicate the information between the client and the servers. So these are some of the services right shown in this diagram here. So the domain name system right resolves internet names to IP addresses. Then the secure shell is used to provide remote access to servers and networking devices. The simple mail transfer protocol sends email messages and attachments from clients to servers and from servers to other email servers. Then the post office protocol is used by email clients to retrieve email and attachments from a remote server. Then the Internet Messaging Access Protocol, IMAP, is used by email clients to retrieve email and attachments from a remote server. The Dynamic Host Configuration Protocol, DHCP, is used to automatically configure devices with IP address and other necessary information to enable them to communicate over a network. Then the Hypertext Transfer Protocol, HTTP, is used by web browsers to request web pages and web servers to transfer the files that make up web pages to the World Wide Web. Then File Transfer Protocol are used for interactive file transfer between systems. Let's look at the domain name system. Alright, so it will be impossible to remember an IP address, right, for all servers hosting services on the internet. So for example, google.com has an IP address. The server actually has an IP address. So imagine where instead of typing google.com, you have to type 192.168.31.1. So imagine you memorizing that for different websites. So you know that letters that form words are much more memorable than clustered numbers. So instead there's a way to there's an easier way to locate servers by associating them with an IP address. So the domain name system provides a way for hosts to use this name to request the IP address of a specific server. So domain name system names are registered and organized on the internet within specific high-level groups of domains. Those are the most common high-level domains of the internet are .com, alright, .edu, and .net. So a domain name server contains a table that associates host names in a domain with corresponding IP address. Alright, so when a client has a name of server, alright, such as a web server, but needs to find the IP address, it sends a request to the DNS server on port 53. Alright, so when the DNS server receives the request, it checks its table to determine the IP address associated with that web server. So if the local DNS server does not have an entry for the requested name, it queries another DNS server within the name. Let's look at web clients and servers. Alright, so when a web client receives the IP address of the web server, alright, the client browser uses the IP address and port 80 to request web service. Because web service are done on the port 80 on the network. So this request is sent to the server using the Hypertext Transfer Protocol. So the request for secure TCP are sent towards port 443. So it is for HTTPS, it goes through port 443, but just open HTTP, it goes to what? Port 80. Alright, so when the server receives a port 80 request, the server responds to the client's request and sends the web page to the client. So the information content of the web page is encoded using specialized markup language, which is HTML, hypertext markup language. Okay. So the HTML coding tells the browser how to format the web page and what graphics and fonts to use HTML the most to use. So HTML is the most commonly used language. So you can have HTML and CSS associated with that HTML and JavaScript connected to that same HTML for functionality and interaction. Alright. So CSS is cascading style sheet. That's what designs your page to look the way it looks like. Alright, if it was just HTML alone, you'd just be having a blank page, right? Just white with pictures and items not really arranged properly. So let's look at FTP clients and servers. So the file transfer protocol provides an easy method to transfer files from one computer to another. A host running a file transfer protocol client software can access an FTP server to perform various file management functions, including file uploads and file downloads. Alright, so the FTP server enables the client to exchange files between devices. Alright, just like you have your Google Drive, you can send the files to someone via the Google Drive, you can download files via the Google Drive. So it also enables clients to manage files remotely by sending file management commands such as delete or rename. Alright, so the FTP service uses two different ports to communicate between client and server. Alright, so to begin the FTP session, so control connection requests are sent to the server using the destination TCP port 21. Alright, so when the session is open, the server uses what? TCP port 20 to transfer data files. Alright, so when sending port 21, when data is going to be sent back to the client from the server, it goes through port 20. So here's an example of a file transfer protocol client software. So most of client operating systems such as Windows, Mac OS, and Linux include a command line interface for file transfer protocol. So there's also a GUI-based file transfer protocol client software that provide a simple drag and drop interface for file transfer protocol. So after logging into the FTP server with the username and password, the user drags files between the local host window and the remote site. The FTP server window so the information is being dragged from the host machine right here towards the remote site right here. Alright. Let's look at the virtual terminals. So virtual terminals, just like we have the telnet, alright, so it provides a standard method of emulating text-based terminal devices over the data network. So telnet servers listen for client requests on TCP port 23. So a connection using telnet is called a virtual terminal, alright, which is VTY, a virtual terminal session or connection. So rather than using a physical device to connect to the server, telnet uses software to create a virtual device that provides the same features of a terminal session with access to the server command line interface. So the client is able to execute commands as if it were locally physically connected to the server. That's why when you use telnet, it shows you all active connection on your particular PC. So there are security issues with telnet. So after a telnet connection is established, users can perform any authorized function on the server just as if they were using a command line session on the server itself. So although the telnet protocol can require a user to log in, it does not support transporting encryption encrypted data. So all data exchanged during kernel session is transported as plain text across the network. So which means that if an attacker is or a threat actor is spooking over your network, he's going to see every single thing you're doing. So that's where the SSH comes in. Alright, so the secure shell protocol offers an alternate and secure method for server access. So the SSH provides a structure for secure remote login and other secure network services. So SSH provides stronger authentication than Telnet and supports transporting session data using encryption. So which means that everything you're going to be doing will not be visible to other people on the network. Email and messaging. So email servers run server software that enable them to interact with clients and with other email servers over the network. So various application protocols used in processing email include the SMTP, Simple Mail Transfer Protocol, POP, and IMAP. So each mail server receives and stores emails for users who have mailboxes configured on their the mail server. So mailboxes are identified by the format your user has configured, just like you have your name at gmail.com. So each user with a mailbox must use an email client to access the mail server and read this message. So an email client can be accessed when you have used mail.google.com on your host machine. So these are different email protocols. The SMTP, the Simple Mail Transfer Protocol, and used by email clients to send messages with local email server. So the local email server then decides if the message is destined for a local mailbox or if the message is addressed to a mailbox other than the server. We also have the post office protocol. So a server that supports POP clients receives and stores messages addressed to its user. So when the client connects to the email server, the messages are downloaded to the client. Alright, by default, messages are not kept on the server after they have been accessed by the client. Alright, so clients contact POP3 servers on the port 110. We looked at all this before. So then there's also the IMAP, which is the Internet Messaging Access Protocol. So this supports servers that support IMAP clients receives and stores messages addressed to its users. So IMAP keeps the messages in the mailboxes of the servers unless they are deleted by the user. So IMAP listens for all client requests on port 143. Then for text messages, so text message enables users to communicate or chat over the internet in real time. So it may also be called instant messages, direct messages, private messages, or chat messages. So text messages software is inbuilt into many online applications, smartphone apps, and social media sites. So text messages services on a computer are usually accessed through web-based clients that is integrated into social media or information sharing sites. Right, so there are also a number of standalone text message clients such as Cisco WebEx Teams, Microsoft Teams, WhatsApp, Facebook, Messenger, and many others that support the transfer of documents, video, music, and audio files. Then for IP calls, alright, so an internet telephony client uses a peer-to-peer technology similar to that used by instant messaging protocols and destination. So protocols and destination ports used by internet telephony applications can vary. So IP telephony makes use of the VoIP technology, which is voice over internet protocol, which converts analog voice signals into digital data. So voice data is encapsulated into IP packets, which carry the phone call through the network. So when the IP phone software has been installed, the user selects a unique name. So a unique name allows calls to be received from one user to the other. Alright, so calls are made to the other user on the same service by selecting username from a list. So a call to a regular telephone, alright, requires using a gateway to access the public switch telephone network. Alright, so and depending on the service, there may be charges associated with this type of call. Alright, so just like you want to call someone, alright, over the network, so your information or your voice data is being converted to digital data and goes via the internet, alright, over the what VOA IP server, alright, and gets to the destination. Alright, this is the application layer summary. So understood the different types of TCP/IP protocols, alright, that enable communication between clients and servers, alright, and also the domain name system, how it is used to convert IP addresses of servers into domain names that are easily memorable by users, and there are grouped into high level domain names are grouped into high levels, alright, such as the .com, the .edu, .net. So there are also .tech, right, .io, and several others. So when a client has the name of server such as a web server but needs to find the IP address, it sends a request to a domain name server on port 53. Alright, so we also talked about how a client receives IP addresses of a web server, and the web browser uses the IP address and port 80 to request for web services. And we also found out that port 80 is for HTTP and port 14443 is for HTTPS. Alright, then for file transfer protocol, when making a request, when sending, alright, it is being sent through port 21, and when the data is being received, it's being received through port 20. And we also thought that SSH can be used in place of telnet, alright, just so that in case a threat actor is poking on your network, alright, you won't be able to see everything that you're doing on the network. Then lastly, we understood that email servers run server software that enables them to interact between clients and other emails, right? And we talked about the SMTP, the POP, and the IMAP, and also the VoIP. Alright, so that's going to be the end of this. Now let's look at module 13. Build a home network. So I'm going to be talking about home network basics, network technologies in the home, wireless standards, wireless traffic control, and setting up the home router. So let's look at the home network basics. Alright, so wireless technology enables network to be easily expanded without limitations of cable connection. Alright, one of the main advantages of wireless is the ability to provide anytime, anywhere connectivity. Alright, so you would not have to deal with the ambiguity of having several wires everywhere connected to a particular device, or having limited ports on a device. Instead, you have to deal with bandwidth. So wireless technology is fairly easy and inexpensive to install. So new and visiting users can join the network quickly and easily. So what are the components of a home network? We could have so apart from the router, we could have devices that are connected to the home network, and that's what makes up your smart home or your home network. Right, you could have your smart television, your laptop, alright, your console, your printers, your scanners, your telephone, right, your IoT devices, right, like your smart refrigerators, smart air conditions. So these are what make up your home network. So this is an example of a home um, router. All right. So you don't you're not getting what a home router is. So when you buy an MTN 5G smart box, so that's an example of a home router. So small businesses and home router typically have two primary types of ports. Right. There is the Ethernet port, which is usually labeled Ethernet or LAN. So this port connects to the internet to the internal switch portion of the router. Then there's internet port, which is used to connect the device to another network, the internet, such as internet through a cable or what DSL modem. So many home routers include a radio antenna, which is inbuilt, alright, or a built-in wireless access point. Now, the Ethernet ports, alright, are used to connect directly to home devices or end devices so that those devices can have access to the internet. Then the WAN now, alright, which is the internet port, is used to send and connect this router or this wireless router to the internet, alright, via the internet of another device, and that device can be a DSL modem. Alright, let's look at network technologies in the home. First of all, we're looking at the electromagnetic spectrum. So wireless technologies use electromagnetic waves to carry information between devices. The electromagnetic spectrum includes such things as the radio and television broadcast band, visible light, X-rays, gamma rays. So each of these have a specific range of wavelengths, correct, and associated energies. So some frequencies are set aside for public use. So these unlicensed sections of the spectrum are incorporated into consumer products, including Wi-Fi routers found in most homes. Alright, so you can see on this diagram we have different wavelengths, alright, in meters. Now in meters we have from 10 to 14, 10 to 12, alright. We have gamma rays, X-rays, ultraviolet, infrared, radar, TV and radio frequency wave, short wave, AM radio wave, right? When you now go deeper within this wavelength, you have what wavelength in nanometers. So let's look at the LAN wireless frequency. So the wireless technology most frequently used in the home network are in the unlicensed 2.4 GHz and 5.0 GHz frequency ranges. So Bluetooth, for example, uses 2.4 GHz band, although there's Bluetooth 5.0, Bluetooth 3.0, right? So other technologies that use the 2.4 GHz and 5 GHz bands are the modern wireless LAN technologies that conforms to the IEEE standard, which is IEEE 802.1111 standard. So you can see this diagram that shows the IEEE standard for the 2.40 to 2.4835 gigahertz. So for devices to be connected to the network wired, okay, this time around not wirelessly, they require some kind of cables, alright. It could be a 5E Ethernet cable, which is the most common wiring used in local area networks. So the cable is made up of 4 pairs of wires, alright, and they are twisted to each other with 4 different colors. You will have orange and white, that's one pair, blue and white, another pair, green and white, another pair, and brown and white, that's the fourth pair. Then there's also coaxial cable. Coaxial cable has an inner wired wire surrounded by a tabular insulating layer that is then surrounded by a tabular conducting shield. So if you want to know a coaxial cable, remember what you usually use to connect your DSTV, your GoTV, your antenna locally, alright, that's a coaxial cable. Then with Ethernet of power line, existing power lines in a house can be used to connect devices to the internet. Let's look at wireless standards. So the main organization responsible for creating this wireless standard is the IEEE. Alright, so the IEEE 802.11 standard governs wireless LAN environment. So the wireless standard for LANs use the 2.4 and 2.5 and 5.0 frequency bands. So collectively, these technologies are referred to as what wireless fidelity. So another organization, which is the Wireless Fidelity Alliance, is responsible for testing wireless local area network devices from different manufacturers. So wireless standards are constantly improving the connectivity and speed of Wi-Fi networks. So there are different wireless settings. For example, network mode. So network mode determines the type of technology that must be supported. So for example, 802.11b, 802.11g, 802.11n, or mixed mode. Right. So there's also the network name, which is the SSID. Alright, so it is used to identify the wireless network. So all devices that wish to participate in the wireless must have the same SSID. So there's also standard channel. So it specifies the channel over which communication will occur. So by default, it's set to auto to allow what AP to determine the optimum channel to use. So the SSID broadcast determines if the SSID will be broadcast to all devices within the range. By default, set to what enabled. So when your SSID is not being broadcast, when you turn on your Wi-Fi to connect to your router, so if your router's SSID is turned off, you're not going to see it, except you have connected to that particular router before and your connection to that particular Wi-Fi is enabled. Alright, so it's one way of being secure or making sure your network is secure. So wireless traffic controls. So wireless channels are created by dividing up the available radio frequency spectrum. So each channel is capable of carrying a different conversation. So multiple APs can function in close proximity as long as they use different channels for communication. But some 5 GHz wireless technologies combine multiple channels to create a single wide channel which provides more bandwidth and increases the data rate. So that's why 5 GHz is always faster than what 2.4 GHz. So collisions occur on shared media during when two or more devices attempt to communicate at the same time. Alright, so Ethernet protocols detect the collision using what? The CSMA, which is carrier sense multiple access with collision avoidance. Alright, so the carrier sense multiple access with collision avoidance creates a reservation on the channel for a specific conversation between devices. So first, a device asks permission from the AP. Alright, so the AP is actually the access point. So with a request to send what message, as if the channel is available, the access point responds with a CTS, alright, which is what clear to send message, which is broadcast to all devices within the network. So when the conversation is complete, the device that requests the channel sends back a broadcast acknowledging message indicating what the channel can be released. Let's look at setting up a home router. So many wireless routers designed for home use have an automatic setup utility that can be used to configure the basic settings on the router. For example, you just turn off, change the name of the SSID, configure a password, and voila, you're done. So to connect to the router using a wired connection, plug an Ethernet patch cable into the network port on the computer, plug the other end into the LAN, one of the LAN ports on the router. So the internet port will connect to the DSL or what cable modem. So after confirming that the computer is connected to the network router and the link light on the network interface card indicating a working connection, alright, the computer needs what? An IP address. So the most network routers are set up so that the computer receives an IP address automatically from the local DHCP server automatically configured on the wireless router. Alright, but you can go back and set it to static. In this case, you now have to impute the IP address manually. So there are several design considerations that should be made before entering the configuration utility or manually configuring the router. What should the network be called, which is the SSID? Alright, so the SSID should not give away information about the network or the device. Alright, so what type of devices will connect to the network? So devices will need to operate with a compatible standard to the access point. So for example, if a device only has the necessary radio for 802.11 B or 802.11G, it will not connect to a wireless router or access point if the configuration only accepts 802.11N or 802.11A or C standards. So we also have MAC address filtering. MAC address filtering can be configured on some routers to identify which hosts are allowed on the network. So for example, the top two devices in the figure are allowed to connect, but not the device on the lower ends. Alright, so you can go and block someone from connecting to your network. So when you block someone, what actually is being blocked is a MAC address. Alright, so when next that MAC address is attempting to connect to that particular router, it will be kicked out again. Alright, so we've come to an end to this module. Alright, and we've understood the basic settings on wireless router. You understand what the different standards is. Alright, I know that the IEEE are responsible for governing the standards of wireless connections. Alright, I know that home routers and small business routers have two types of ports primarily, which is the Ethernet port and the Internet port. I know the Ethernet port is used to connect to your host devices, and the Internet port is used to connect to a DSL or cable modem. Alright, so we've come to an end of this. So you need to remember what the 5 GHz is in the electromagnetic spectrum. What internet point means. The AP, which is the access point, Wi-Fi, wireless fidelity, or SSID. Alright, SSID broadcast. Okay. What the RTS means, the CTS, and the acknowledgement and MAC address filtering means. Alright. Lastly, in this class, we'll be looking at the module 14, connect to the internet. So I'm looking at the ISP connectivity option, which is the internet service provider, the network virtualization, mobile device connectivity. So let's look at ISP connectivity options. So the internet service provider provides a link between the home network and the internet. So internet service provider can be the local cable provider, a landline telephone service provider, the cellular network, or an independent provider who uses bandwidth on the physical network infrastructure of another company. So an internet service provider may offer additional services to their customers, such as email account, network storage, website hosting, and automated backup and security service. So internet service providers are critical to communications across the global internet. So each ISP connects to other ISPs to form a network of links that interconnects users all over the world. So here you can see different ISPs, right? Web hosting, file hosting. These are different ISP services, right, to a unique ISP. So the interconnections of ISPs that forms the backbone of the internet is a complex web of fiber optic cables with expensive networking switches and routers that direct the flow of information between source and destination host. So, but however, the connection to an ISP from a house or small office, home office, can be just a connection through modem or use a router in between to provide additional security configurations. So most small office, home office customers use cable or digital subscriber line to connect to the internet service provider. So the cable, all right, is typically offered by cable television service providers. The internet digital signal is carried on the same coaxial cable that delivers cable television. All right, so a special cable modem separates the internet data signal from other signals carried on the cable. Now, the digital subscriber line provides a high bandwidth, always on connection to the internet. So, digital subscriber line runs over a telephone line, which was the line split into three channels. One channel is for voice, the other two channels are for data, which is whereby one is for downloading, the other is for what? Uploading. So other SP connections for homes could be cellular. Alright, so the cellular internet access is a cell phone network to connect. Alright, so performance will be limited by the capabilities of the phone and the cell tower to which it is connected to. Then another is the satellite. So satellite service is a good option for homes or offices that do not have access to digital subscriber line or cable. So satellite dishes, see, for example, in the previous image, they require a clear line of sight so that there can be clear connection, right, between the host and the satellite, so that the satellite will be visible to the host and the host will be visible to the satellite. All right. So it might be difficult in heavily wooded areas or places with other overhead obstructions. All right, so when there are walls around, that might hinder the stability or the speed of the connection. Then we have dial-up telephone, so an inexpensive option that uses any phone line and a modem. So to connect to the ISP, a user calls the ISP access phone number. The low bandwidth provided by a dial-up modem connection is usually not sufficient for large data transfer. Just for example, when you set up a Google Meet call, you will see a dial-up phone number there if you want to connect to the call. So that's an example of a dial-up telephone. Let's look at network virtualization. So network virtualization is possible with the help of cloud computing. So cloud computing is one of the ways that we can access and store data. So cloud computing allows us to store personal files, even backup an entire drive on servers over the internet. So applications such as word processing and photo editing can be accessed using the cloud. Cloud computing is possible because of data centers. Alright. So data centers house servers, storage devices, and other network infrastructure equipment so that they are accessible by everyone on the network. So there are types of cloud. Yes, public cloud, private cloud, hybrid cloud, community cloud. Public cloud applications. These are applications and services offered in a public cloud. Alright, these are that are offered publicly so that they can be accessible by anyone. So services may be free or they are offered on a pay as you go model or pay as you use model. Then there is private cloud. So applications and services offered in the private cloud are intended for a specific organization or entity such as the government. So just like organization can use a private cloud so that every of its infrastructure that is being used on the cloud is only accessible by their staff. Then we have hybrid cloud. So hybrid cloud is made up of two or more clouds. So it could be private, it could be public. All right, parts could be private, parts could be public, where each part remains a separate object, but both are connected using a single architecture. Then there's community cloud. A community cloud is created for exclusive use by a specific community. So the functional needs have been customized for the community, for example, healthcare organizations. So there are different cloud services, all right. The three main cloud computing services identified by the National Institute of Standard and Technology are in their special publication 800 to 145 are SaaS, PaaS, IaaS. Alright, there's also ITaaS. So SaaS, which is security software as a service. So here the cloud provider is responsible for access to application and services such as email communication and Microsoft 365 that are delivered over the internet. Then we have platform as a service. So the cloud provider is responsible for providing user access to development tools and services used to deliver the application. Just like you have your Google Drive, alright, Microsoft Azure. So there's also infrastructure as a service. So the cloud provider is responsible for giving IT managers access to network equipment, virtualized network services, and supporting network infrastructure. So this is where cloud infrastructure comes in. Things like AWS, Microsoft Azure, GCP. Alright. So cloud service providers have extended this model to also provide IT support for each of the cloud computing services. So there's difference between cloud computing and virtualization. So cloud computing is one of the ways that we can access and store data. Meanwhile, virtualization is using technology to create virtualized version of computing resources. So virtualizing technology enables a host operating system to support one or more client operating system. Alright, so for example, you are running a Windows operating system and you store a Linux operating system on your Windows device. That's an example of virtualization. And you can only do this with the help of hypervisors. So the transformation of dedicated servers to virtualized servers is being rapidly implemented in data centers and enterprise networks. So a major problem of using dedicated servers is that they are underused because they often sit idle for long periods of time. So virtualization addresses this issue. So one or more advantage of virtualization is overall reduced cost. So less equipment is required, less energy is consumed, less space is required. And other benefits could include easier prototyping, faster server provisioning, increased server uptime, improved disaster recovery. Now, what are hypervisors? Hypervisor is a program of firmware or hardware that adds an abstract layer on top of the physical layer. So the abstraction layer is used to create virtual machines which have access to all the hardware of the physical machine, such as your CPU. Alright, has access to your memory, your disk controllers, and your network interface cards. Alright, so there's type 2 hypervisors and there's type 1 hypervisors. So type 2 hypervisors use the hosted approach. Type 1 hypervisors use the bare metal approach. Now let me explain further. So a type 2 hypervisor is a software that creates and runs virtual machine instances on a host computer. So a type 2 hypervisor is installed on top of the existing operating system on the host. So one or more additional operating system instances are installed on top of what the hypervisors. So for example, your operating system, you install a VirtualBox as a software on your Windows operating system, and within that VirtualBox you can install different instances of operating system. You can install Unix OS, Linux OS, Windows OS again on that VirtualBox, which is the hypervisor. Then for the type 1 hypervisor, It is installed directly on the server or networking hardware. So Type 1 hypervisors have direct access to the hardware resources, and they are more efficient than hosted architectures. So instances of an operating system are installed on the hypervisor. So there's something called network virtualization. Alright, so virtualization separates the operating system from the hardware. So server virtualization takes advantage of idle resources and consolidates the number of required servers. So it allows for multiple operating systems to exist on a single network platform, or a single hardware platform rather. So network virtualization combines traditional networking hardware and software network resources into a software-based entity. So network virtualization combines traditional networking hardware and software network resources into a software-based entity, which is a virtual network. The control plane is used to make data forwarding decisions. So a network device contains two planes, right? The control plane and the data plane. So the control plane is used to make data forwarding decisions. The control plane contains layer 2 and layer 3 route forwarding mechanisms, such as the IPv4 and IPv6 routing tables and the ARP table. So information sent to the control plane is processed by the CPU. The data plane, also called the forwarding plane, alright, is typically the switch fabric connecting the various network ports on a device. So the data plane for each device is used to forward traffic flows. So routers and switches use information from the control plane to forward incoming traffic out of the appropriate egress or outgoing interface. Information in the data plane is typically processed by a special data plane processor without the CPU getting involved. So network virtualization combines networking hardware and software network resources into a software-based entity, which is a virtual network. Software-defined networking is a network architecture that virtualizes the network. So the software-defined networking is the separation of the control plane and data plane. The control plane function is removed from each device and is performed by a centralized controller. The centralized controller communicates control plane functions to each device. So each device can focus on forwarding data while the centralized controller manages the data flow. So in a traditional router or switch architecture, the control plane and data plane function occur in the same device. So the SDN management of the control plane is moved to a centralized SDN controller. So the SDN controller is a logical entity that enables network administrators to manage and dictate how the data plane or switches and routers should handle network traffic. Let's look at mobile device connectivity. A mobile device may be equipped with multiple wireless connection options such as a cellular, Wi-Fi, and Bluetooth. For data communication, it is advisable to connect to Wi-Fi network when possible because data used over Wi-Fi does not count against the cellular data plan. Wi-Fi radios use less power than cellular radios. Connecting to Wi-Fi networks conserve battery power. So when using Wi-Fi on your phone, your phone battery lasts longer when using Wi-Fi than when it uses its cellular data. Precautions should be taken to protect Wi-Fi communication on mobile devices. So never send login or password information using unencrypted text or authentic. So use a VPN connection when possible if you are sending sensitive data. So enable security on home networks. Use WPA2 or higher encryption for security. For example, when setting up your password on your Wi-Fi hotspot, you see the option for WPA or WPA2 for encryption settings. So to connect an Android or iOS device when it is within the coverage range of a Wi-Fi network, turn on the Wi-Fi and the device, then search for all available Wi-Fi networks and display them in a list. So touch the Wi-Fi network in the list to connect, enter the password needed, and voila, you'll be connected to the network. So if a mobile device does not prompt to connect the Wi-Fi network, the network SSID broadcast may be turned off, or a device may not be set to connect automatically. So you can manually configure the Wi-Fi settings on the mobile device. So remember that SSIDs and paraphrases must be typed exactly as entered in the wireless router setup, or the device will not connect properly. So when you want to connect manually, you can just type the name of the SSID. Alright, that's the name that you gave your router or MiFi. Type it on your phone or your system. Put the password if there's password available, and it should connect automatically. So a detailed configuration procedural on an Android device is slightly different from that of iOS devices. So mobile devices are programmed to use a Wi-Fi network for internet if one is available and a device can connect the access point and receive an IP address. So if no Wi-Fi network is available, the device uses the cellular data capability if it was configured. So once your Wi-Fi is off, there's no Wi-Fi available, automatically your data turns on. Right, so cellular data plans are offered by cell phone carriers. That's your SIM card. Alright, so the bandwidth limitation and charges for usage vary widely by the carrier and by the plan within carriers. So that is varied by the network you're using, whether MTN, Airtel, or Glo, for example, or H2O or AT&T, and depending on the kind of subscription, data subscription you're using. So most of the time, transitions from one network to another are performed automatically. So now, Bluetooth technology provides a simple way for mobile devices to connect to each other and to wireless accessories. Alright, so Bluetooth is wireless, automatic, and use very little power. So up to 8 Bluetooth devices can be connected to a host at any one time. So a few examples of how devices use Bluetooth are hands-free headsets, keyboard or mouse, stereo control, car speaker phone, Tethering, mobile speaker. So Tethering is a mobile device can connect to another mobile device or computer to share a network connection. That's to share internet using what Bluetooth Tethering. Alright, so Tethering can be performed with a Wi-Fi connection or what a USB. So Bluetooth pairing occurs when two Bluetooth devices establish a connection to share resources. So for the devices to pair, the Bluetooth radios are turned on and one device begins searching for the other device. The other devices must be set to discoverable mode so that they are visible to the other device. Alright, so when the device wants to connect to is being detected, you just tap on it, alright, and request if you want to pair, and you click on pair. So when a Bluetooth device is in discoverable mode, it transmits the following information, which is what? The name, the Bluetooth class, services that the device can use. Alright, it could be audio only, it could be audio and video, and it could be audio, video, and data. So taking information such as the feature or the Bluetooth specification that it supports. So during the pairing process, a personal identification number may be requested to authenticate the pairing process. So the PIN is often a number, but can also be a numeric code or passkey. Alright, so we've understood the different services provided by the ISP, alright, and the few methods to connect to an ISP. You understood what virtualization technology is, you understood what cloud computing is, alright, what software-defined networking is, alright, and how software-defined networking is expected to mediate and facilitate communication between application and network elements, and how mobile devices can connect to each other and also connect to the internet, and how Bluetooth connection requires pairing between what Bluetooth-enabled devices. Alright, so and some terms that we heard are the ISP, the cable. I talked about the coaxial cable, the twisted pair cable. Right. Also talk about cloud computing, DSL, that's digital subscriber line, different cloud services, software as a service, platform as a service, infrastructure as a service, IT as a service. Also, I talk about hypervisors. An example of an hypervisor is Oracle VirtualBox. Right. Another one is VMware. And there's a type 1, type 2 hypervisors. Type 2 hypervisors are the ones like the Oracle VirtualBox that you install on your host machine or on your PC. Type 1 hypervisors are installed on servers, alright, so that the virtualized environments can have direct access to the hardware. And I talked about the control plane and data plane. Okay, I also talked about Bluetooth pairing. Alright, thank you very much for staying with me. Stay tuned for the next class.